Hi and welcome to this video where we look at linear functions and how we can best sketch them from the given function. Well, linear function sketching. So what I've got here is a set of axes and a linear function. Just as a couple of reminders, first of all, remember this axes for linear functions, particularly when there's no context, well, it could go into the negatives in either direction. So I need to recognise that. In this case, I've done a bit of pre-planning, which I encourage you to do. Think about, well, where is this function going to be? And now I can see a few things like it's going to cross the y-intercept here. We'll talk about that later. And it's going to be pretty steep. It's just going to look like that. So I've kind of drawn out my axes to suit what I need it to look like. And it helps me to get my scale so I can still have a reasonably accurate scale. But of course your scale doesn't have to be exactly right. It could go up in 10s here and 1s there. That's okay, as long as it's clear. I've also got arrows on both ends. Make sure that you're recognising it could go in both directions forever. And I've got my y and my x. If it can't go in both directions forever, so in statistics generally we might not have negatives or negatives down here, well then you don't have the arrows there, and we represent that differently. So just keep in mind the way that you represent all your diagrams. Now, we have y equals 2x minus 1, and I'm going to show you a couple of ways to build this sketch. The first is a table of values. You need to be aware of the method of a table of values. A table of values is set up like this, x and y, or it could be A and B or T and C or whatever it is, and it's where you get a set of information. So I'm going to build a table of values around 4 data points, and I'm going to use 0, 1, 2 and 3 as my data points. Now these are randomly, arbitrarily chosen x values, just whatever numbers. 0, 1, 2 and 3 are nice numbers to choose though. But I could also choose 0, 7, 10 and 28, or -5, 0, 5 and 10. This is your standard. Table of values, you choose the x values, and then you determine the equivalent y values, and that will make a set of coordinates. So let's do this y value calculation. So for the first one, where x is equal to 0, hopefully you can see y is equal to 2 times 0 minus 1, which equals -1. So I'll pop a little -1 in there. And this is now a coordinate when x equals 0, which is the y-axis, y is equal to -1, which is here. And I'm going to mark that coordinate in this case as well. It's all part of my communication. And the second one, when x is equal to 1, y is equal to 2 times 1 minus 1, which is equal to 1. So I'll pop a 1 there. And now I can mark 1, 1, which is about here. Obviously you might have graph paper or a ruler, be a little bit more accurate. 2 and 3, because 2 times 3 minus 1 is 3. So my apologies, 2 times 2, that will be a 2, minus 1 is 3. So 2 and 3 is here. And then 3 and 5 is here. 2, 3, 3, 5. And now I've got a straight line. Now of course I need to recognise that the straight line doesn't just stop at those data points. It does go on, it's just that I've chosen 0, 1, 2, 3, but it goes in either direction as well, so I've got those arrows again to show that. So that's sketching a linear function from a table of values. So I could also sketch a linear function using a couple other methods. I've got to pop my arrows on here. Of course there are a couple of other methods. So the first thing I'm going to do is just show you a really generic easy method, which is like the table of values, but it's just about plotting a couple of points. Remember, we only need 2 data points to be able to sketch a linear function. So I could just find 2 points. When x equals 3, y equals 2 times 3 minus 1 is 5. And just plot 3, 5. When x equals -2, y equals -2 times 2, which is -4 minus 1 is -5. So -2, -5, and then connect those data points up. That's probably the most trivial way, and it's basically just a table of values, but broken down into a smaller idea and concept. 2 data points will get you your graph. So with the idea that 2 data points will get you your graph, let's talk about our next method, which is to use intercept form, which will almost always work, and we'll talk about when it won't work in a minute. So intercept form is about finding the y and the x intercept. Now a little bit later on you'll learn that the y-intercept is the number that's by itself, the constant in this form. We'll talk about that in a minute. The y-intercept is -1. What I want to point out though is the y-intercept occurs on this y-axis. And that y-axis represents every data point where x equals 0. So to get the y-intercept, we just let x equal 0. And so of course we get y is equal to 2 times 0 minus 1, which is negative 1. So our y-intercept is negative 1. And then we can get our x-intercept. This is intercept method. So our x-intercept is where it crosses the x-axis, and that occurs at a data point where y is equal to 0. The x-axis represents all the data points where y equals 0. So we just let y equal 0. And this one's often a little bit trickier because of the way we set up our linear functions. But we get this, 0 is equal to 2x minus 1. We have to solve an equation now. 1 equals 2x. We divide by 2, and we get x is equal to a half. So there's our x-intercept, and then we connect those to produce our straight line graph. There it is. Now, this will work perfectly well, except for a function that passes through the origin, because the x and the y-intercept are the same point. So then you only have one data point, and we don't know whether it's this graph, or this graph, or this graph. We don't have enough information. So just keep that in mind. If it passes through the origin, the dead giveaway is that there's no constant value, then this won't work quite as well. And the third method I want to talk to you about is just the idea of using our function. So I'm going to keep this graph and use this graph, but what I'm going to do here is I'm going to talk briefly about what our function represents. And this is prior learning that you've probably heard of, maybe you don't remember, but let's revise. Y equals mx plus c is the standard form of our linear function. That's what it usually looks like. So what I'm going to point out here is the m, if you recall, is the gradient, and the plus c is the y-intercept. As long as it's in this form, it has to be a single y and then something x plus c. And it's the something in front of the x, we call that the coefficient. The coefficient of x is the gradient, and then the constant term is the y-intercept, if it's in this form. We can see this guy is in this form. So at the moment we're dealing with this function, y equals 2x minus 1. So we have a y-intercept of minus 1, which we've already plotted here, and we have a gradient of 2. So what that gradient means is it's a steepness measure. So the gradient measures steepness. So then, if we started our y-axis and we move along 1, the gradient will tell us how much we go up and down by. So if I move along 1 to here, that's 1, I move up 2, this is negative 1, I go up to 2 to 1. If I move along 1, I go up 2, which is now 3, and that's now 2. So you can see I'm building these data points on my linear function. I can very quickly get a couple of data points and then sketch this function. You might be asked to use a specific method. Intercept method's great. This method here is pretty good, but depending on the gradient, really, it can become a bit of a hassle. And of course, just having a table of values and an understanding of how to get some data points, because you only need 2 data points. I would recommend getting 3. It gives you a checkpoint, just to make sure the third point lies on the line that you've developed. Well, thanks for joining me, and I really hope that's helped. All the best.